graduated from the University of Pune in India in 2012, majoring in Electronics and Telecommunications. He is currently pursuing a master's degree in computer engineering at George Mason University, through which Pushkar won the Best Working Project Award, Microprocessor coursework, for his obstacle avoidance car. Pushkar has also organized and presented at Autonomous Robotics workshops, and as an undergraduate, served as a member of his college technical team. Pushkar's research interests include embedded systems, computer architecture, and digital design.
Good morning all, and thank you Dr. Holmes. I'm Pushkar Mahajan, and today I'll be presenting on factors affecting the performance of microprocessor towards better performing architecture. So before going into my research, I want to ask you a question. So ever wondered why your computer is slow? Everybody, I know that everybody hates slow computer. So the question is why? So the answer to this question, your computer processor is slow. So that's why I tried to answer this question and trying to find out the performance factors which are affecting the performance of the microprocessor. Before going into my research, I want to give you a brief background about computer architecture. What is computer architecture? What is a microprocessor? While I read my abstract, I want you to read this abstract. I'll read my valuable summary in Marathi. Superscalar प्रोसेसरच्या कार्यक्षेत्राला कारणीभूत असणारी घटक जसे की पाइपलाइन आर्किटेक्चर, कॅश मेमरी आणि रिऑर्डर बफर कशी मल्टी-कोर प्रोसेसरच्या कार्यक्षेत्राला सुधारू शकते आणि याची चर्चा या सादरीकरणात मानक कामगिरी मूल्यांकन कॉर्पोरेशन या संस्थेच्या बेंचमार्कच्या मदतीने विविध मायक्रोप्रोसेसर आर्किटेक्चरचे विश्लेषण सादर केले जाईल. So as I said before, today I'll be presenting what is a brief overview of computer architecture, then what are the performance factors affecting computer architecture, then current problems related in computer architecture, then I'll compare different architectures such as superscalar architecture, VLIW architecture, multi-core architecture. Then based on these differences, I'll evaluate these architectures and give some recommendations to go further. So let me give you a brief explanation about computer architecture. So computer has inputs, outputs, devices, memories. So the most important factor of computer is microprocessor. And microprocessor contains cache memory, register buffer, reorder buffer. These are the factors affecting the performance. So we'll go by each step. So what is computer architecture? Computer architecture is a science of selecting and interconnecting hardware components to create a computer that meets functional performance and power. As you can see on the screen, there are different components of computer. So the computer consists of input, output devices, memories, and the processor is one tiny little part of computer. So let me tell you where exactly the computer architecture lies. So as you can see from the diagram, microarchitecture stays in the middle. So if you go down below from the microarchitecture, there is a hardware section, and if you go up, there is a software section. So as early designers, we were focusing on computer architects were focusing on from programming languages to circuit level, and now the architects are focusing on domain, which is specific to the instruction set architecture and to the gate level. So as we go further beyond the computer architecture, there are some factors which we should consider. As you go up in the software section, you should consider parallel computing, security. As we go down from the computer architecture and hardware level, we should focus on reliability, power. So as I said, the main important factor in computer architecture is processor. So what is a microprocessor? So microprocessor is a multi-purpose programmable device. It accepts digital data as an input and it processes the input according to programmable instructions stored in the memory. So basically it's a small chip. As you can see here, it's an integrated IC that is programming all these things. So if you go inside the processor, you'll find these different parameters. So there's a cache memory, there's reorder buffers, there are register files. These are different parameters which consist, which are there in the microprocessor. So what are the factors which affect the performance of the microprocessor? So I listed out some factors. The factors are, you can categorize them as hardware parameters and software parameters. So hardware parameters are cache memory, then register file, reorder buffers, instruction queue, ALUs, clock rate, address bus. And software parameters consist of compilers, algorithms, and operating system. Today I'll be focusing on hardware parameters, especially focusing on cache memories, reorder buffer, and instruction queue. So, but however, these factors are there. We are increasing performance day by day. Every year we are improving the performance by 50%, as you can see from this graph. So what contributes to this improvement? So according to Moore, the number of transistors per square inch on integrated circuits have doubled every year since integrated circuit was invented. So you can see that we are increasing the transistor density in our microprocessors, but however we are not able to go beyond the clock rate, certain clock rate. So we are facing like we can't go beyond 3 gigahertz of clock, because if you go beyond 3 gigahertz, the power dissipation is more. And because of power dissipation, we are facing heat problems. So, as I said, this is two major challenges. There are two major challenges. One is tight power budgets and achieving high performance. So, why do we need high performance? So, because there are advancements in science and technology, demands of performance of microprocessor designers, while microprocessors are facing performance bottlenecks. So, which industries require these higher performances? So there are wireless communications which requires higher data rates, more complex interfaces, and workstations requires such as games and all. They require higher resolution, realism, and accuracy. And supercomputers require fidelity and time scales. So there is no limit for performance to be for supercomputers to be more improved. So this brings to my research question. So my research question is, how do hardware parameters such as pipeline architecture, cache memory, reorder buffers affect performance of superscalar and multi-core processors? How can multi-core processors satisfy high computing needs caused by advancement in science and technology? So to answer this question, I compared 3 different architectures. So the first architecture I've compared is superscalar architecture. Superscalar architecture has some strengths and some limitations. The strengths are include instruction level parallelism. What that means is we can fetch more instruction at the same time. And this superscalar architectures were compiler-based optimization, and it required more hardware support than the other architectures. So what are the limitations? Because of hardware support, it requires it has data dependency and control dependency. So resource conflicts, such as if you are accessing one hardware parameter, you need the other parameter for the other instruction. So resource conflicts is there. So to overcome these conflicts, we propose VLIW architecture. So what is VLIW architecture? The VLIW stands for Verilog Instruction Word. So basically, in this architecture, we designed a simpler hardware, but we designed a strong compiler so that we can accommodate all instruction in a single instruction and execute it on simple hardware. But this has limitations such as it needs more powerful compiler. We need to design more powerful compiler, and the larger bandwidth memory and register file bandwidth. Because of we increase the instruction queue, the instruction size, the bandwidth requirements is more, and that's why the increased core size is there. So To overcome these limitations, we propose multi-core architectures. So multi-core architectures are the most effective architectures right now. They have higher performance than any other architecture. And the multi-core processors have shared cache or private cache. So we can achieve cache coherency and high clock frequency because of shared or private cache. So, and because of multi-core, we can run parallelly, we can run multiple threads on parallel processing. So what are the limitations? The limitations are adjusting to operating system, because in multi-core, we are running different cores at a time, so we need some operating systems adjustment. And because of we have different cache systems, the algorithms are needed to for cache coherency coverage. And because there are many cores, it's difficult to manage thermally because power dissipation is more in this case. So these are some examples of microprocessors, such as superscalar processor, Intel Pentium 3, VLIW is Titanium. Multi-core is core to duo, and SMT, that is simultaneous multi-rate processor, is Intel Pentium 4. So I've compared these architectures. This is using SPEC in 2000 benchmarks, and as you can see from the result, there is no leader in performance. So why this is so? Because the AMD and AMD processors, which leads to spike in performance, followed by Pentium 4 and Titanium 2, and Titanium 2 processors, which are VLIW architectures, were the failure for Intel Corporation. So and that's why we propose multi-core processors. So the Intel came up with Xeon family of multi-core processors. We, as generation by generation, we are improving the performance of multi-core processors. So as you can see, the IPC, that is the performance factor of multi-core processor, is increasing by generation. And still, so my suggestion is to even more improve this performance of these multi-core architectures is to implement deeper pipeline proposed by Carman and Springer. And we can have more configurable cache memory and self-adaptive cache memory to save power. And we can reduce the complexity of designing reorder buffers in out-of-order processors to have more performance to the for the processors. So coming back to the general question which you had, which processor to buy when you go to buy a processor. So I recommend, if you are using for personal uses, you can go for quad cores or dual cores. If you are designing an embedded system which does not require high computing, you can go for single core. If you are designing a data center, so you can go for multi-core. For high computing, you need multi-core processors. And in conclusion, I have briefly discussed what is computer architecture. I have discussed the current problems which are related in microprocessors, comparisons of different architectures. I've evaluated these performances and recommended some suggestions. I gave some suggestions to improve more performance. And the future of our multi-core processor is heterogeneous microprocessor. So this is a new thing which is coming up right now. Where heterogeneous microprocessors are like the one core is running on different architecture and the other core is running on different architecture. So, and the other future scope is integration of CPU and GPU. Professors and researchers are now proposing that we can integrate GPUs, that is graphical processing unit and central processing unit, to combine them together and have more performance. So by 2012, we can achieve this performance.